So because graphing is so important, we're going to go back and practice a little more graphing quadratic functions, which end up being parabolas. So let's start with number 1. We have y equals x squared minus 4. And of course, the very first step to graphing a parabola is to find the vertex. And we all know that a vertex is a coordinate, an x and a y value. And we also know that the vertex x value is found with this formula, negative b over 2 times a. And we should also know that when we use it, we're going to put parentheses instead of the letters. Then we're going to plug in our values according to a, b, and c on our standard form quadratic trinomial equation. Now, as you can see, this is not a quadratic trinomial, it's a quadratic binomial. In other words, your a value is with the x squared, which is 1. Your b value is the term in the middle, which is not even there, so your b value is 0, and your c value is negative 4. So your b value is 0, so you're going to plug in a 0 for b and a 1 for a. Now, what does that mean? That your x value of your vertex will be negative 0 divided by 2, which is still 0. Right? So your vertex x value will be 0. Now, how do you find the y value once you already have your x value? You plug it in and you could find your y value. So we're going to take the x value of 0 and plug it in right in here, and you should be able to get the y value. It's really easy. 0 squared is 0, minus 4 is negative 4. As a matter of fact, whether you're doing the vertex or whether you're doing an xy table, which we're going to be doing shortly, anytime you plug in a 0 into a standard form quadratic equation, when you plug in 0, your answer will always be the c value, which happens to be negative 4. So in this case, our vertex is 0, negative 4. Let me put it the same color there, 0, negative 4. So let's graph 0, negative 1, 2, 3, 4. It's down here, way at the bottom. And of course, we have an axis of symmetry. I normally draw the dotted line. It's kind of pointless to do it because it's crystal clear that the axis of symmetry is the y-axis itself. You could do the dotted line if you want. But anyways, we need more points. So that's where we go to an xy table. And normally I say plug in the easy number 0, but I'm not going to do that because we already plugged in 0 for the vertex. So we need to plug in other numbers. So another easy number would be what? 1. Perfect. So let's plug in a 1. And how easy is that? 1 squared is 1, and 1 take away 4 is negative 3. So we have the coordinate 1, negative 3. So on my graph, I go 1 on the x, negative 1, 2, 3, and I put a dot right here. And of course, I could mirror it over. I will mirror it over, but it's still too small of a parabola to leave. So on the quiz, if you left a tiny little parabola like this guy, I took off some type of points. You need to actually extend it so we can get the full feel of the parabola here. So let's plug in another value. What other number would be good to plug in? 2 would be great to plug in, right? So let's plug in 2. If you want to show your work, go for it. Plugging in 2, you're going to have 2 squared minus 4. And 2 squared is 4, and 4 minus 4 is 0. So when I plug in 2, I get out a 0. So that's a coordinate 2 on the x, 1, 2, 0 on the y. That's actually right on the x-axis. So I put a dot right there. And let's map them over to the other side. So this guy that's 1 unit away, let's go 1 unit this way and put a dot right there. The other one, it's 2 units away. Let's go 2 units away this way and put a dot right there. And if we wanted to, we could plug in another one just for fun. Let's plug in 3. And if I did do that, what is 3 squared? 9. And what's 9 take away 4? 5. So when I plug in a 3, I get out a 5. Let's just see if it fits. I'm not sure if it's going to be on this graph. Let's see. 1, 2, 3. 1, 2, 3, 4, 5 right on the edge. Yeah, so we could actually pull it off and put that coordinate right there. We could map it over to the other side. 1, 2, 3. 1, 2, 3. Put a dot right there. And that is our perfect parabola. All we have to do is connect the dots right through those points. Put some arrows on it because it does go up forever. And that's our perfect parabola. Let's talk about a couple other things, especially because the instructions here state the domain and the range. Okay, so keep in mind that the domain values are always your x values. And when we say x values, we're talking about the x-axis that runs left to right. So my question to you is this: does the parabola exist on the positive numbers on x? Does it go that way? Yes, it does, right? Even though it goes up, it continues to go this way forever. In other words, I could, even numerically, I plugged in the number 1, plugged in the number 2, I plugged in the number 3, and numerically, I could plug in the number 5 if I wanted to, right? 5 squared is 25, 25 take away 4 is 21. What does that mean? That I'd be at 5 and then 21, way up there, right? You could plug in 10 if you want. 10 squared is 100, 100 minus 4 is 96, so you'd have to go 10 and then 96 way up there, right? So the domain, the x values, you could plug in any number you want positive, any number you want negative, so the domain is x equals all real numbers. And that's the correct domain for any parabola, whether it opens up or down, because all parabolas go left and right forever. Even though they go up or they go down, they still go left and right forever, whether they're going up or down. So the domain's always x equals all real numbers. How about the range? The range are your y values, and we do see that this parabola is going up forever. This parabola does exist way up here and forever going up, and it also goes forever going up. So the y values are for sure infinite up here, but as you go from left to right on the parabola, it's going down, going down, going down, going down. It reaches a certain low point, which is called the minimum, and it doesn't go below that value, so it stops here and then it goes back up. That's why this vertex is actually called the minimum value. So if we wanted to, we could also say, hey, the min value on this parabola is the coordinate of the vertex 0, -4. And we could say that also about this parabola. But we're talking about the range. We need the range here. The range are your y values. And we know that this parabola, when you're talking about the y's, it's going up and down. This parabola is down here, the lowest point, and it exists above that value. So what is this lowest point of the parabola? It's -4. And the parabola exists above it. So when you're talking about range, you're talking about the y values that are above -4. Now, with inequality symbols, we're talking about y values that are greater than or equal to -4. So right here we've stated pretty much everything that there is to know about a parabola, right? We know the vertex. The vertex was 0, 4. We found that with the formula. Not only that, the vertex coordinate is the same thing as your minimum value, because your vertex is either your lowest or your highest point, depending on whether it opens up or down. And we also stated the domain and the range, which are your x and y values of your parabola. The only other extra thing that we could state is the axis of symmetry equation. The axis of symmetry equation, now remember the axis of symmetry is that dotted green line that we have right here. Well, it's not dotted anymore, I just made it solid. Sorry about that. But anyways, the axis of symmetry is simply the vertical line that goes right through the x value of the vertex. So if they asked you for the axis of symmetry equation, that would simply be x equals the x value of your vertex. So just for your own sake of knowledge here, the axis of symmetry will always be x equals the x value of your vertex. And that's everything that there is to say about a parabola. They didn't even ask us to do all this, right? They asked us to graph it, to state the vertex, and to state the domain and range. They didn't say min, max. They didn't ask for axis of symmetry equation. I just wrote everything that we could say about an equation. Let's jump to number 3, and let's find the vertex. And we're going to find the vertex with the x equals -b/2a formula, which, of course, we're going to do parentheses to plug in the values. And we find the a, b, and c value by looking at our standard form quadratic trinomial equation. So the b value we could clearly see is -2. And the a value is +1 because there is no number right there. So our x value will be a -2 is +2, and 2 times 1 is 2. 2/2 is 1, so our vertex x value is 1. Once you have the vertex x value, all you got to do is plug it in into the x's, because that's the x value, and that way you could find out what the y is. So there's my equation, but instead of x's, I put parentheses, and now let's plug in the value of 1 for x, and let's work this out 1 squared is 1. 2 times 1 is 2. So you really have 1 minus 2 minus 6. So 1 minus 2 is negative 1, and negative 1 minus 6 is negative 7. So your vertex is 1 comma negative 7. So that's your vertex. That is the most important point on any parabola. So let's graph that vertex. 1, negative 7. That would be 1 on the x, negative 1, 2, 3, 4, 5, 6, 7. Almost on the edge right there. And through that value, we need an axis of symmetry. So let me do that in green like always. And if somebody asked you for the equation of that axis of symmetry, it would simply be x equals the x value of your vertex, which we know is 1. That's the equation of the axis of symmetry. They're not even asking for that on this one. But we have the vertex, the most important point. We also know that this parabola opens up or down. What do you guys think? Up. Why? Because the a value is positive, right? The a value is 1, which is positive, which means that it opens up. If there would have been a negative sign in front of the x squared, it opened down, right? But because it's positive, it's opening up. Okay, so we know it's opening up. We know that this is the vertex. We know that that's the minimum value because it's opening up. We already know the axis of symmetry. We need more coordinates to graph this thing. So what do we do? XY table is what we do. Well, yeah, we're going to be plugging in values into x and pulling out answers for y. So what would be the easiest number to plug in into your XY table? 0 is easy, right? Okay, let's plug in 0, because whenever you plug in 0 in there and in here and in here, your answer will be the c value, which is negative 6. That always is the case. Whenever you plug in 0, your answer is always a c value when it's a standard form quadratic equation. Anyways, 0, negative 6, let's do that. 0 on the x, negative 1, 2, 3, 4, 5, 6. And of course, we could reflect that onto the other side and put a dot right here. As you can see, we need more points. This parabola is not big enough to just, whoop, that was ugly. This parabola is not big enough to just leave it like that. It's too tiny. So we need more coordinates. So what other number would be nice to plug in? Well, we already plugged in 0. We got out negative 6. We technically already plugged in a 1. And you're thinking, where? Where do we plug in a 1? On the vertex, right? The vertex, we plugged in a 1. We got out a negative 7. So we already know that one. So that's not going to help us if I plug in a 1. What other number would you like to plug in? 2 would be good, right? Or negative 1. Either one's good. I want to go with 2, all right? So let's go back to number 3, or zoom in on number 3 here, and let's plug in a 2. There's my original equation. Let's plug in a 2 right there. 2 squared is 4. Let me write it above. And then 2 times 2 is 4. So you have 4 take away 4, take away 6. So 4 take away 4 is 0. 0 take away 6 is negative 6. Whoa, I did something wrong there then. No, I didn't. That was ridiculous. That was a total waste of time. Why is that? Because if I plug in 2 on the x, negative 6 on the y, we already had that coordinate by reflecting it. So that was a total waste of time. What other number do I have to plug in? 3. Dang, sorry about that. Okay, so let's go back to here. Now let's just do this in our heads here. Let's go 3 squared. What's 3 squared? 9. Okay. And what's 2 times 3? 6. So we have 9 take away 6. What's 9 take away 6? 3. And what's 3 take away 6 at the very end? 3 take away 6 at the very end. Negative 3. So when I plug in 3, I get out a negative 3. And now I'll be ready to graph that and map it over to the other side. So if I go 3, 1, 2, 3, negative 1, 2, 3, I'm right here. And map it over to the other side, which it's 2 units away. 2 units away, you'll be right there. And ladies and gentlemen, that's already good enough. I guess it would be nice to plug in one more. Let's plug in 4 just for kicks. Just for kicks. So 4 squared is 16. 2 times 4 is 8. 16 take away 8 is 8. 8 take away 6 is 2. So when I plug in a 4, I get out a 2. Let me plot that up there. 1, 2, 3, 4, 2. It's right on the edge. You could map it over to the other side. And that is your final answer, your final graph. We're done. The domain is x equals all real numbers. the range is y is greater than or equal to -7.